Hey everyone, thanks for joining us today. My name is Tyler Hill with ThreatX. We're thrilled to be here. Recently, we announced the launch of a brand new product of ours, Runtime Application API Security. And today's session is going to focus on API security with eBPF, really with the focus on vulnerability detection and runtime observability. And today we're going to walk through details of what we announced, why we're doing what we're doing, and deep dive into the world of eBPF and API security to really understand the shifting paradigm in the API security landscape. And in today's session, you're going to learn a lot about some of the proprietary technology of what we're doing at ThreatX and how we're really leveraging some of the emerging eBPF technologies to keep our customers safe in the modern world. Now, let's talk about the API landscape. Currently, from a security tool set, it's very fragmented right now. There's a broad variety of tool sets out there that all have pros and cons. Depending on your end game and use case, there's different tool sets that are geared towards different use cases. And these have been long employed by a number of organizations, whether it's from static testing to stopping attacks. And all of these things really are fragmented, and there's no ubiquitous connection between a lot of these pieces. And ultimately, when we think of API security as a holistic objective, really all these things need to come together and talk together in some way, shape, or form, right? And at ThreatX, what we're setting out to do is really change the world for API security by thinking of the product landscape from code time to runtime, from broad coverage to granular coverage, and really trying to nail a gap in the middle that brings together the testing side with the real-time runtime side to be able to see not only emerging threats in your APIs, but be able to stop attacks at the end of the day in real time. And as we think about this really spectrum of code time to runtime and broad attack vectors to very granular attack vectors, we've set out to really focus on that right-hand side there to really bring the DAS world in sync with the runtime and the live kind of real-time attack world. And so, what you'll see throughout the course of this presentation is really focused on our deployment side, going deep diving into the sensor, understanding how we're detecting threats, what we're able to see, that ultimately in a follow-up presentation, be sure not to miss it, we'll go into more of the workflow. So if we think about our solution, high level, it's geared towards customers that run Kubernetes in the cloud. So any public cloud platform that's out there, the big three, GCP, AWS, Azure, as long as it's running native Kubernetes, our sensor is designed to support it. And when our sensor is deployed, you'll be able to see events and traffic within workloads in real time. And when our sensors deploy, immediately they start generating events that go up to the ThreatX cloud that enables us to see vulnerabilities in real time, runtime events. And this is really where the eBPF side comes in, that we're able to leverage what's called syscalls to be able to see deep into the application workload. We'll talk about that in a little bit. And last but not least, API profiling to understand the heuristics and the fine-grained details of a customer's API interface. So when we go back and go to the vulnerability assessment, really, what you're able to do is have a much more informed perspective and accurate posture to produce the right test plans, ensure that vulnerabilities are accounted for and mitigated. So before we dive in, I want to talk about a little bit eBPF and its role of security. So a quick show of hands, who's here, who's heard of eBPF before? Okay, cool. Well, for those that haven't, eBPF is a revolutionary kernel technology that allows the developers to write custom code that can be loaded into the kernel dynamically. Now, for those that aren't familiar with a kernel is essentially the abstraction layer that sits between a piece of software and running hardware. And sitting at that layer, what we can do is really tap into a new generation of highly performant networking, observability, and security tools using eBPF. To highlight a few things that eBPF really excels at is that it's the performance tracing of almost any aspect of the system, high performance networking with built-in visibility, and detecting and preventing malicious activity. And so when an application is running in the user space as we know it today, you load, you're interacting with the program, it's making calls to the kernel. Maybe it wants to load a file from disk. Maybe it wants to load a file off the internet or make a networking call. Everything that happens flows through the kernel. And by virtue of eBPF living and having full visibility into kernel activities, we're able to see everything that's going on within the application to ensure the integrity and fidelity of your running applications, make sure that they're not compromised or there's other hidden or malicious activity going on. And really, that's where our RAP sensor excels. So that's a high-level overview of eBPF. A lot of great resources out there we can direct you to, but eBPF at its core is really the underpinning technology of our latest solution. And so that's why we're so excited about it, because it's really pushing the frontier of what's been possible and also doing it in a new, innovative way that's going to change the future of security. Now, let's talk about a little bit around the vulnerabilities and malicious activities that we can see with ThreatX RAP. So first and foremost, API vulnerabilities. Your applications are running, they're processing API transactions. Those transactions often happen significant amounts of volume and can occur spikes over time, and they'll often come in waves depending on what type of business you run. And really, as those transactions are coming through, most of the time it's going to be normal traffic, but there could be malicious transactions within those payloads. And common examples of vulnerabilities that our system looks for is things like server-side request forgery or excessive resource consumption or authentication issues or data exposures and more. Ultimately, as those transactions are hitting your applications, we're seeing all of those in real time to be able to build a profile of kind of your network flows and API endpoints that could be out there, using a very non-invasive technology to be able to see all of that, see fine-grained details, right? The next thing is suspicious syscalls. So what we talked about on the last slide, eBPF really at its core sits at the kernel level within the Linux runtime. And a syscall is simply a fancy way of seeing a call from an application go down to the hardware. Right. So if I want to load a file from disk, or if I want to write something, or if I want to, there's a number of activities an application can be requested. But simply put, if someone's using the syscall in a malicious way, for example, to access unauthorized data or to manipulate a process within your application or to try to go undetected, that's where eBPF really shines with a module called Tracepoint to be able to see an alert on things that are anomalous or otherwise shouldn't be happening. So that's number two, detecting suspicious syscalls. And last but not least is API profiling and schema generation. So we talked about the API vulnerability level, being able to see specific endpoints, the interfaces of your APIs, and be able to understand ultimately your entire attack surface that you have out there, if it's a public interface, private interface. And what we're able to do with all the event data is roll that up and aggregate it to have a very detailed perspective on what types of interface details are being actively used. So for example, if you had 10 different APIs out in the wild, out in production, we would be able to, based on live transactions, roll those up and understand down to the method level, down to the parameter level, down to very fine-grained details, so you know exactly how your APIs are being invoked, for better or worse. If there's offending transactions that don't comply with the schema, we'll be able to see those types of things. And ultimately, we can use that to generate a detailed test plan for you to go back and say, hey, I think I found an API vulnerability. I know exactly how it's hitting my interface in the API by virtue of having that schema and that definition for the profile. What we can go back and do is confirm that exploit lives out there in the wild or in a non-production environment to be able to go back and say, aha, we know exactly where we need to patch this. From a dev side. We'll also have the option too from the ThreatX side, if they have a WAF in place, to be able to virtually patch that as well. So really what it enables that customer to do is to effectively identify vulnerabilities, whether they're in production or in a non-prod environment, and address them and mitigate them before they get out into the wild and prevent the opportunity for an attacker to be able to take action on those from a proactive perspective. So 3 things again: identifying vulnerabilities, detecting suspicious syscalls, and API profiling and schema generation are really the core underpinning of what we're doing and what we call our sidecar sensor. Now, on the topic of the sensor, let's take a deep dive and understand what's actually going on under the hood. So our targeted sensors are really designed to be deployed within Kubernetes environments, K8s, and really 2 main components of our solution that would be deployed into customers' environment. You can think of it almost an on-prem deployment or in your own cloud, but we really have 2 main components. One is our sensor and one is our analyzer. And essentially they come together for capturing data, processing data, and decision-making. Those are the 3 main things that they do at the core. And essentially, as API transactions are hitting your tech stack or applications, we're able to see all of those transactions with our lightweight sidecar sensor that's deployed against the application pod. We'll be able to extract all the metadata, headers, request body, and send them up from a decoupled perspective to our analyzer for processing. What happens there is that we're able to run really inspection and rules against the types of requests that are coming in, and we can take action on them to send events up to the ThreatX platform. Doing it this way allows us to be really close to the application, get that fine-grained insight into what's happening within the application without burdening the application layer with heavy processing. So it's a decoupled approach in terms of getting that fine-grained level of insight, putting it asynchronously on the analyzer to be able to see all the data. And from there, what we do is bubble it up into the ThreatX cloud, where you have the analytics and the dashboards to be able to understand all the events that are happening within your ecosystem. The sensor and analyzer are built for high performance scale. The analyzer will be deployed out in your K8 environment in a ThreatX namespace that we would provide to you, but with a reference Helm chart, deploys out, and you could have many sensors that map back to a single analyzer based on your workload to be able to scale up and scale down with your application pods. And ultimately what that does is allow the sensors to live right next to that app in a non-impactful way, where it wouldn't prevent any performance issues, and give that analyzer still that full capability to see all the ingress and egress data coming off the sensor, be able to understand what's happening and bubble the right events up that ultimately a security analyst or end user needs to know about. This is a quick sneak preview of what the real-time runtime insights would look like within our dashboard, where we're able to see really fine-grained details around what's going on in terms of those syscalls within a running application. And we give you a lot of rich dashboards that allow you to see where, for example, commands are being invoked from within your applications, and ultimately, how did they get there? Correlated events that may be related to them, and other fine-grained detail that as a security analyst you would want to know about in terms of being able to take action and stop any malicious process. Thank you very much for attending today. Now I'd like to hand it over to my colleague, Abby Bennett, for an overview on workflow and vulnerability management included within our ThreatX Prevent solution. Abby, over to you.
My name is Abby Bennett. I'm the Director of Product Management at ThreatX, and thanks for joining me. Today I want to talk about identifying API vulnerabilities and optimizing workflow management. Let's go ahead and jump in. Okay, so if you look at the 2 graphs on the right-hand side of the screen, you'll notice that exploited vulnerabilities and web applications are the top attack types and attack vectors for virtual currency for last year's Verizon 2023 data breach report. This just quickly highlights the need and then the need of vulnerability management within applications. But vulnerability management is complex. There are just such a high number of vulnerabilities and so many different types. It can be daunting for security analysts and for developers to keep track of and manage the vulnerabilities. Not to mention, it's hard to prioritize fixes. Once a vulnerability is actually prioritized, The remediation process can be really slow. It can take weeks, months, even up to a year just to get one application vulnerability remediated. On top of that, the API landscape is ever evolving. So APIs continuously emerge. They're continuously spinning up, and attackers are getting more sophisticated. Discovery and visibility is a challenge. So understanding the vulnerabilities across your production and pre-production environments is one thing, but also managing APIs and applications across your entire organization and getting a clear picture of vulnerabilities in that regard is also a challenge. Because of the dynamic nature of APIs and code constantly being pushed to production, keeping test cases up to date for actual vulnerability management can also be daunting. It can be a hard task when you're having to manually keep those updated unless you have the right tools in place. Just a quick quote from Gartner, but they highlight that vulnerability management is a critical operation that really helps organizations to identify assets, mitigate threats, and then meet compliance mandates. So we talked about some of the necessities of application vulnerability management. Let's get into really the underlying challenge of traditional application security testing methods. So really, I just chose to focus on one. And this one challenge kind of underscores, or really it has a domino effect and causes many other challenges within vulnerability management. But that is the lack of production level real-time visibility. Because of this lack of production real-time visibility, it causes blind spots in security coverage. So when you don't know or don't have a clear picture of the vulnerabilities in real time, how can you identify vulnerabilities? How can you detect and remediate 0 days or detect anomalous behavior before it's too late? Prolonged remediation is another challenge. So longer time to remediation, right? When you don't have that real-time visibility, you can't identify and prioritize the most critical vulnerabilities in real time immediately. It's the slower response that leads to an increase in potential damage because these APIs and vulnerabilities are just being exposed to the wild, waiting for an exploit to happen. And then manual intervention. These AST methods, with the lack of production level visibility, they sometimes cause the need for utilization of separate tools like a DAST or a SAST. Some customers that we've talked to utilize up to 5 or 6 different tools. And what happens is they end up trying to paint this picture of their attack surface or their vulnerabilities across the board from pre-production to production by using separate tools and merging the data, consolidating the data. And once this consolidation effort is done, it's very manual. Once it's complete, code has been pushed to production and is being pushed to production. So everything has actually changed since they were able to do that. So it really causes inconsistent security assessments across environments, even though the goal is to get that comprehensive visibility. And so what ends up happening with traditional AST methods is you just get very fragmented visibility. You get these blind spots, the prolonged remediation, and then manual intervention necessary to actually keep track of all of the vulnerabilities across your environments. We'll talk about how ThreatX actually works and how we can help in the next slide, but I just want to identify really quickly kind of the opposite of these, but how we can help solve for some of these challenges. With ThreatX, there are no blind spots. We have an always active monitoring solution. We're monitoring real time. We're monitoring across pre-production and production environments wherever we're deployed. We're seeing network and runtime traffic. So we're seeing everything at once in real time so that we never have any gaps or blind spots. From a remediation perspective, because of this, we're able to remediate in real time. We're identifying vulnerabilities and have the ability to prioritize them in real time and offer almost immediate remediation as well. We'll talk about that in the next slide. We're fully automated, so there's no need for utilization of separate tools. You don't need a separate DAST or SaaS solution just to get that comprehensive visibility that's on the right-hand side. We're fully automated. We're able to run scans in automation and able to basically prioritize and visualize all the vulnerabilities automatically without that manual intervention. All right, so we talked to the challenge. Let's talk about ThreatX and our runtime API and application protection solution and the kind of life cycle of how we can help, how ThreatX works, how we can help solve some of those challenges in the previous slide. It all starts with production level real-time monitoring. We're utilizing eBPF, as Tyler spoke to before, to get that really deep, granular context and visibility at runtime. We're seeing the syscalls, we're seeing the network and the runtime traffic. And then from there, we're able to create dynamic schemas and dynamic test plans with what we're actually seeing in production. We're able to utilize that to then go and very specifically target endpoints and APIs to confirm that vulnerabilities do exist and are exploitable. From there, these vulnerability results are populated in our dashboard where we provide workflows for customers to actually manage the vulnerabilities in the application. We have remediation options as well. Virtual patching at the edge, at ThreatX's edge, is an option. If you don't, or if you're not a ThreatX customer, we can also virtually patch via a third-party WAF integration. And then also we've integrated with Jira to provide seamless ticketing solution to be able to pass the vulnerability information, the where, the what, to the dev team to be able to remediate at the source. All of this within this lifecycle just continues, but all of this is how we're able to really provide our customers a very comprehensive picture of all of their vulnerabilities across pre-production and production environments. So what does the dashboard look like? This is just a 60,000 foot high level overview of the dashboard. But again, as we're seeing these vulnerability events through our eBPF sensor, we're populating these in our dashboard. And we're doing risk analysis on these vulnerabilities to provide our customers a really quick overview of what's at most risk, which vulnerabilities are the most critical, and where should they start taking a look first. We've got simple workflows to manage these vulnerabilities, whether it is keeping the status up to date of a vulnerability or whether it's choosing to manually run an active scan. And then, of course, we just spoke to the remediation steps from a ticketing perspective and then remediation via virtual patching at the edge. So really, we've spoken to kind of the necessity and the criticality of vulnerability management. We've spoken to some of the challenges of traditional AST methods, the blind spots, the prolonged remediation, the manual intervention, and then how ThreatX can help with our always actively monitoring solution to get that comprehensive visibility from pre-production to production. So please come join us for an interactive demo. It'll only take 5 minutes or so.
If you don't get a chance to join us for an active demo, be sure to check out our website at threatx.com, and please feel free to reach out if you have any questions. Thank you so much for joining us today.